Hi there. In this video, we'll be going through how to draw the tan graph. So in the two previous videos, we already went through the sine graph and the cos graph. Those two are very similar, but the tan graph, it looks a bit different. So let us begin. So we'll be drawing the graph of y is equal to tan theta for where theta is an element between the values of 0 degrees and 360 degrees. And this is our domain. Okay, so let me draw our y and x axis. So the y, this one's going to be slightly longer. I think this is fine. And then we can put x-axis there, or theta. So this is theta, and this is y. And this over here is 0 degrees. So the first thing is that the graph of tan theta does not have a minimum or a maximum value. However, we're still going to include the key values we tend to look at when we're looking at y, which is 1 and -1. So over here, we will indicate that this is y is equal to 1, and down here, this is y is -1. But it does not have a minimum or a maximum. Next is our domain is from 0 to 360. So I'm going to put those values over there, the critical ones. So 360 is our maximum. And then another critical point is 180 degrees. And then 90 degrees, which is midway. And 270 degrees, which is halfway between 180 and 360. Okay, so the graph of tan, it starts at 0 degrees. So let's use green for this one. So at 0, it's also at 0. And then at 45, which is halfway between 0 and 90, that is when it is equal to +1. So that's when y is equal to 1. And then at 90 degrees, it actually does not exist. So there we have an asymptote. So let me draw a dotted line to indicate that here the graph does not exist. It's an asymptote. Another asymptote is also at 270 degrees. So here it also does not exist. Okay, so these are the two asymptotes when we look at the graph of tan theta between 0 degrees and 360. All right, going back to where it actually does exist. So in between 90 and 180, at 135, which is 90 degrees plus 45 degrees, that is when it is at -1. So it's not a minimum, but it's just a point. And then at 180, the y value is 0. And I hope you've picked up the pattern that we add another 45 degrees and it is back at 1. And then at 270, once again, it does not exist. Okay, and then beyond 270, we add another 45 degrees. And then it is 315 where it's back at -1. And then at 360, it's at 0. So now I've just indicated the critical points, but I still haven't revealed the shape of the graph. So now let's join all of these dots so that you can see the true shape of the tan theta graph. Right, so at 0, it curves and then goes to 45 and then approaches that. This one isn't that good. Oops, my eraser is too big. Let me draw a better. So it's going to approach the asymptote. So here it goes like that. And then it just keeps approaching the asymptote. So let's extend the asymptote. So it's never going to reach that point. It will just keep approaching the 90-degree asymptote line, meaning that it's just going to go up to infinity. Okay, and then from here, it goes from negative infinity down here, and then it approaches like that, and then it keeps going, and then it curves some more like that, and then it just keeps going up and approaching the asymptote like this. So it's got a squiggly shape type of. I think I should redraw this. So this is more like that. I think that's better. And then lastly, to join these two, it starts from negative infinity going up like that. So this is how the graph of tan theta looks like. Very different from cos and sine. So the key things to remember when you are drawing the tan theta is where is y equal to 0? That is at 0 degrees and 360 and 180. Next, where is the asymptotes? So the asymptotes are at 90 degrees and 270. And then next you want to ask, where is y equal to positive 1? And that is at 45. Let me indicate it. 45 at 135 at 225. And then here we are at 315. So this is when it's positive 1, and also I've indicated when it's negative 1. And then at the asymptotes, that's where it's approaching either positive infinity or negative infinity, depending on which direction you're coming from. So when you're coming from 0 approaching to 90, it's going all the way to positive infinity. So here it's approaching positive infinity, and going down here from 90, it's coming from negative infinity, and then it increases up until it reaches positive infinity again. And then here it always starts from negative infinity and then increases. Well, here we stopped at 360, but if you are to add another 90 degrees, you will see that it will be approaching positive infinity. Okay, so I hope you've picked up the pattern for the graph of tan theta when it comes to its shape. So let's now look at its key features. So for its range, because it does not have an amplitude, so I think let me rather include all the other ones that I started with. So amplitude, it does not have. Because it doesn't have those type of crests with a maximum and a minimum value. It's going to positive infinity and negative infinity, meaning that it has no maximum or minimum. Maximum or minimum. Okay. Now we can look at a range, because it definitely has a range, even though it might not seem like it. So the range is y is an element of real numbers, because it's approaching negative infinity and positive infinity. meaning that it's all the y values that are real. We can also write it like this, where we say it's from negative. So because it's infinity, we use curved brackets because infinity is not a number. So it's from negative infinity to positive infinity. So y is an element. So that's another way we can write it. Okay, and then the period. So we said that the period is the degrees that are required to complete a wave. Looking at the graph of tan theta, you can see that for you to have a complete wave, it's when you're going from negative infinity to positive infinity. So in this sketch, we find that is occurring between 90 degrees over here, and then it goes up all the way there. So this is a complete wave. This one here is not a complete wave, and there it's not a complete wave. So if the wave is between 90 and 270, the actual width of this is the period. So 270 minus 90 degrees is 180. So the period of the tan graph is actually 180 degrees. And then the asymptotes, because these are also key features. So we have asymptotes at x is equal to 90 degrees and at x being 270. While we were using theta, so actually here we can replace this x with theta. So theta being 90 and theta being 270. That's a better way of putting it. So that's where our asymptotes exist, where the graph does not have a value. So if you are to put tan 90 degrees in a calculator, it won't give you a value. It'll give you an error. Okay, so that is it for the graph of tan theta.